So, welcome all, and today we are here with Juan Pablo. He's an award winning mechatronics engineer graduate and studied a Master in Science in Electronical and Computing Engineering. Juan Pablo, welcome to have you here today. I'll give you the floor to introduce yourself and I'll pull up the presentation for you. So, good luck with the session.
Thank you, thank you. Let me share the slides and start. So in this session, I'm going to tell you about the HoloBoard, an innovative mixed reality application for the Microsoft HoloLens 2. Well, this is an overview of the session. I will present you an innovative mixed reality application for the Microsoft HoloLens 2 that can transform how a specific subject is taught, learned, and assessed in the metaverse classroom experience. This app targets to help students of electronic courses to develop the intuition needed to build electronic circuits. It is inspired by what tools I would have wanted to have when I was starting my major in engineering. And well, by the end of this session, I hope I have convinced you that by exploiting the technology provided by the HoloLens 2, mixed reality apps have the power to have a great impact in higher education, offering an enhanced and engaging learning experience. I would like to start with one of my favorite quotes since I started my bachelor's. Science can amuse and fascinate us all, but it is engineering that changed the world, from Isaac Asimov. But how do we teach engineering to the students? Well, when learning, one of the best ways to retain new knowledge is by doing. Unfortunately, such practical approach is not possible in many fields due to limitations like scale, cost requirements, lack of equipment, or capabilities. This happens in engineering, but there are also other areas of study where real practicing might be hard, for instance, physics, biology, and medicine. So the same question arises again. How do we teach and learn these disciplines? And maybe even more important question, how we do it in an engaging way? The answer to these two questions is by doing a simulation. because among the advantages of doing simulations, we can have the visual learning, which might enhance the comprehension of complex topics. It is easy to set up. The repeatability of multiple tests under different conditions, and conducting experiments and simulations can help saving time and money. And to illustrate how simulations may help in teaching students, here are some examples of the fields that I mentioned before. In engineering, we get access to complex machinery or systems. In physics, it is possible to understand fields that are not visible, like electricity and magnetism. In biology, we can study complexity of cellular and molecular structures. And finally, in medicine, we can use mixed reality to explore organ systems, muscles, and bones of the human body. Now, when it comes to electronics, building a circuit for the first time could be overwhelming. Students have to be able to read electronic diagrams, like the one here in the right, understand them, and then assemble the right components in the right place to get something like this. On one side, you have a variety of components with very different functionality, like resistors, capacitors, inductors, transistors, uh, and so on and so forth. And they exist in so many different values, and you have to understand how these values affect the behaviors of the circuit. And on the other hand, you have to learn how to read how to read the electrical diagrams, because in the schematics, the components do not look like the real components. Like for example, here, this is the schematic of the diode, the one above, and the one in the bottom is the real LED. So, in order to address all these difficulties, I propose the HoloBoard app, a mixed reality solution to help students of electronic courses on how to build circuits, and that provides concise information regarding the elements that conform the circuits. The idea was inspired on what tools I would have wanted to have when I was studying my major in engineering. And you might be wondering, why using mixed reality when students can find guidance using any of the multiple software available for electronic simulation, or even by following YouTube tutorials? Well, the truth is that it is possible to learn by these techniques, but with the simulation software, it always remains a feeling of lack of real interaction. And in the case of following tutorials, they can be felt impersonal. And also, there is the fact that there is no easy way to find the error if making a mistake while building the circuit. So, to start with the HoloBoard app, the first thing you will see when you show your palm to the HoloLens, you will have a menu, and in this menu you will have to choose the unit of the course. These units are meant to be focused on each of the main electronic components, like the resistor, the capacitor, sensors, and so on and so forth. For this prototype, the prototype that I built, there is only access for the first unit, which is the resistors. Then, when selecting the resistors unit, the next thing we will see is the lesson menu. Here, the students have to choose which specific circuit he or she wants to build. For the time being, 3 lessons are available for the first unit: the resistor, potentiometer, and pull-up and pull-down resistor. And after selecting the lesson, a holographic breadboard will appear in front of the student, as well as the components needed for that specific lesson. The palm up menu now will change to a menu with all the available components, which is the one showing here in the right. For this menu, I wanted to replicate how one selects components from a real component box. So the selection is very intuitive, and any selected item would be instantiated and will be ready to be interactable. I want to show you the pipeline on how I did, for example, the resistor selector, where you have to choose the specific value depending on the color of the bands. So when a resistor wants to be deployed, first its value has to be chosen, by changing the color of the bands. And as the color of the resistor bands are selected, the current value of the resistor is displayed in order to select the correct resistor value, the one over here. Once the desired value has been selected, or better said, the color of each band has been selected, this resistor can be created by clicking the select button. And this is the workflow of how I did the resistor's value. So first, I had to be able to change the material of the 3D object in Unity. Then I had to control this change by clicking different buttons. Oop, sorry, is this one? To change the same band by clicking on different buttons. Then this one, the third one. The next thing I had to do was to create a menu holding the buttons for each band of the resistor. And the value of the resistor, the one over here, changed accordingly to the color of the band. And finally, once the value was selected, I was able to create the resistor with the selected value. So I can change the resistor value, and the same resistor I'm seeing here in the menu is the one, the object, the 3D object that I will create. And this value, of course, will affect the functionality of the circuit. Okay, so for this prototype, since its objective is to guide the students on how to build circuits, instead of giving the liberty to place the components anywhere in the board, I decided to restrict the final position of the components to specific target locations. The objects are attached to the target location as soon as they approach their final position, which is represented by the golden ghost. After completing the circuit, the simulation can be started and the student can use the interactable components, if there is any, like buttons or potentiometers. So in this video, you will see 3 different ways of starting the simulation. The first one, the simulation starts immediately after the placement of all the components, like in real life. Then the next one will be starting the simulation with a button, like in simulation softwares. And the last one will be to start the simulation with voice commands. So here, all the components are being dragged to the target position. And as I mentioned, the target position is shown by this golden ghost. And as soon as I place the last component, the simulation starts. Then the next one, I will have to press the start button to start the simulation. And the last one will be with voice command. Start the simulation. There you go. Now, back to the menu. There is also the options menu containing 4 buttons: the manipulation, task description, help and tips, and components information. The first one, manipulation, enables the manipulation of the whole circuit, and it can be used to move, rotate, and scale the circuit to the convenience of the student. Task description gives a brief insight of the lesson as well as the diagram of the circuit. The help and tips button will show a booklet containing on each page a concise information about all the electronic components, and components information will display tooltips on each of the components. All these 4 buttons have a toggle behavior, meaning that to select them, we have to click the button, and to deselect them, we have to click the button again. In this video, you will see a first look of the HoloBoard app running on Unity. You will see the navigation through the menu, the lessons opening, the placement of components, spawning objects of the components from the box, and using the side buttons. So let me press play. So first we will see the unit button. When we select the unit, we will select the lesson. And after the lesson, we will see the components box where we can spawn different components. So even though we have a battery already placed there, we can create as many batteries as we want because we can select that from the box component. Then clicking back to go back to the lessons menu, the manipulation button will allow the user to move and to scale down and rotate the board. And that's it. That was the first demonstration of the first look of the HoloBoard app. Um, Also, the menu has three side buttons: the go back, the pin button, and enable voice commands. The first of them is to go back when navigating through the menus. If you are inside a lesson, the back button will take you back to the lesson menu, and if you are in the lesson menu, it will take you back to the unit menu. Then the pin button, the one over here, the one with the little pin, is used to enable the follow me behavior by locking the menu to the local position of the user. And the best for the end. The last button of this group is used to enable voice commands, the one with the microphone over here. Uh, for this purpose, I used a machine learning model for speech to text translation and then accessed the generated string to trigger any of the possible commands. These voice commands could be used to start the simulation or to toggle any of the buttons inside of the option menu. To trigger these voice commands, the user just have to say, for example, start the simulation or enable task description or disable components information. So let me show you a video using these three side buttons. So I just enabled the voice button. Start the simulation. Enable task description. And as you expect, all the buttons are pressable and they behave the way they should behave in real life. Disable task description. Enable help. The help is the little booklet that I mentioned before. This booklet contains information about all the components used in the lessons and some special tips on how to use them. For example, what is a resistor, how it is used, the importance of using the polarity of the LED, potentiometer, the button, how is the internal connection of this component. Disable help. Enable components information. These are the tooltips that are on top of each of the components to see what's their name. But these tooltips can be also used to display important information like the voltage components information or the value of the resistor or enable manipulation. So as you can see, I was toggling all the options menu by voice command and disable them as well. to move around the whole board, scale it up, scale it down.
Disable manipulation.
And well, I have to mention that one of the reasons why I wanted to make it scalable was that because when you are doing circuits in real life, sometimes the holes are so little that you cannot see where exactly they go. So if you can scale up the whole board and the whole components, the user or the student will be able to see exactly the position of the components to do like correct circuit, building circuit. And well, this is the application working on the HoloLens.
So the first
Because before I was showing you the simulation in Unity, and once you deploy them, you will do the same things, but it looks just better in the
thing
HoloLens.
we see when I show my phone is the units menu. Here we can see all the units in our electronic course, but since we are starting, just the first one is available, resistors, and we will select it. After that, the lesson menu is open, and we will start with the first one, resistor. And now we have the description. It says, in this first lesson, you will learn how to connect a resistor and a LED to a 9-volt battery. And we have the diagram to help ourselves in building this circuit. So now we can disable the task description and enable the manipulation to scale down our model and make the build of the circuit easier. So we can disable now. And in case we have any doubts, we have this booklet that contains information about all the elements. So we start with the protoboard, with the breadboard, how it works. We have here the power supply, columns, how they work, some tips on how to use the protoboard, then the component area, how to do connections on the protoboard, then a brief explanation of each of the elements. First, we have the resistor, how they work. Then the LED. For example, here explains one important tip, which is that when you connect a LED, you have to check the polarity because it matters. If you connect the LED in the opposite way, it will not light up. Then the potentiometer and the button. And we can access this booklet whenever we want with this help and tips button. And once we finish placing all of them, a button will appear to start the simulation. So when I press the button, the LED lights up. Okay, we can go back and start the next lesson, the potentiometer. Let's see the last description. And now this time it says, replace the resistor of the previous lesson by a potentiometer and use it to adjust the brightness of the LED. Okay, so it's the same, but this time we just have to replace the resistor by a potentiometer. Let's scale down to make it easier to see. Okay, there you go. And again, we can disable the manipulation. And we do again the placement of the components. And we start the simulation. And the LED lights off. And here in the potentiometer, we can control the angle of the wiper, and the intensity of the LED will vary according to the angle of the wiper. So we move it, and the intensity changes. Okay, now we can go to the third lesson. description. Let me read this. So it says, in this lesson you will learn the difference between a pull-up resistor and a pull-down resistor. And here is the description of each circuit. We can hide it, enable the manipulation again to move our circuit. And this time we have a lot of circuits, a lot of components. So if we want some help, first let's disable the manipulation. And if we want some help, we can enable the tooltips that tell us what are the components of this circuit. We can disable them and start placing our elements. And the best for the end is that to start the simulation, we can do it by the button, or we can also do it by voice command. So to do so, we have to click in this button to enable the microphone. So if we say start the simulation, now the pull-up resistor will light up. And if we press the button, it should turn off. So if we click, it's off. If we release, it's on. And the opposite behavior happens with the pull-down resistor. Normal state is off. If we press, it will come off. It will come on. And we can also enable the tooltips with voice command by saying enable components information. And as well, we can disable them by voice command by saying disable disable components information. And well, last but not least, here in our component box, we have all the elements available, and we can pick any of them and instantiate them in our circuit for future lessons. So, yeah, that's it. Thank you for watching. Stop recording.
So the only difference between this video and the demonstration videos that I've been showing you before is that in this case, it was everything from the displayed in the HoloLens. And maybe you were wondering if the placement and all the manipulation was accurate, because sometimes the hand didn't look like I was clicking on the buttons, but it's just matter of the recording, because when you are using the HoloLens, everything is very, very accurate. How you manipulate and control the holograms. So let's keep going. Now, for future development, in order to give an even more immersive learning of experience, I would like to extend the reach of interaction by voice and change it to a machine learning model for natural language understanding, rather than using specific sentences for each command. Then also lessons for all the units would be offered, and all the components in the component box would be used. Also, it would be possible to change the value of the components, and naturally, this value will affect the circuit's behavior, like changing the value not only of the resistors, but also changing the value of capacitors, transistors, every single component. Another improvement would include to give the student full control of components placement instead of using target locations, and also the liberty to create and simulate circuits outside the lessons. In addition, uh, as an important part when building circuits, values and voltage of each element will be shown. And last but not least, I would like to implement language diversity in instructions given by text and audio, so the HoloBoard app would reach more people. Sorry. Language diversity, like Spanish, English, Arabic, or any other language. So just to finalize, to give some conclusions, when using mixed reality, usually the objective is to copy real objects into virtual twins. However, my approach is to do exactly the opposite, that the user copies a virtual object into a virtual twin. Sorry, to copy a virtual object into a real twin. And this is the kind of outcome that someone would expect when using the HoloBoard. So in the potentiometer lesson, the intensity of the LED is expected to change accordingly to the angle of the wiper. And in the pull up and pull down lesson, the LEDs have to stay in their initial state until the button is pressed. So for the pull up, the initial state is to be on, and when we press the button, the LED goes off, which is the first one. Natural state is on, when we press it's off. And for the pull down resistor, the natural state is off, when we press goes on. So the HoloBoard app will help students to develop the intuition needed to read electronic diagrams correctly, implement the circuits using the right components, and most importantly, to understand what the circuit does. I am certain that apps of this kind have the potential to innovate education and have a real-world impact, because the HoloBoard app will be useful not just for students with a background in engineering, but for anyone interested in developing a project involving electronics. To finalize, I just want to state that I am very passionate about the whole mixed reality spectrum, and after experiencing the HoloLens2, I am absolutely convinced that with them you can bring your ideas to reality, to the mixed reality. And I want to leave you with another quote that fits like a glove to the spirit of this project, but also to education during this technological era. This quote is from Carl Sagan, and it says, "In a world of transition, students and teachers both need to teach themselves one essential skill, learning how to learn." And this is it. This is it from my part. Thank you, everyone. If you want to see all the details of the project, you can visit this link, or you can scan directly the QR code.
Thank you, JP, for your presentation. You weren't able to hear me. Um, I was looking if there were any questions from viewers. I didn't see any yet, but I have a few questions for you that maybe you could elaborate a little bit more on. So, coming back to the last element that you presented, one of the things that you would like towards the future is that you can actually read a schematic. Is that correct?
Um, like in general, the objective is to help the user to be able to read the schematic, to
Okay, okay.
know.
So this, yeah, so the simulation itself doesn't read the schematic, because that would be ultimately, of course, very cool if you could actually enter a schematic and then have the interaction on the virtual board that you need to basically reproduce there.
Well, actually, that was not the way I thought about it. But now that you mention it, actually would be really cool to take, for example, the HoloLens or your phone, scanning of the schematic, and then tell you like, hey, this is the real circuit, how it might look.
Yeah, no worries. I send you an invoice for the tip. No worries. So, yeah, so that actually, well, it triggered my brain. And actually, I have a background in electronics, so I perfectly understood where you were coming from. So, um, I have a few other questions. Did you also, so it's a prototype, but did you also
Yes.
test it with other, let's say, fellow students or maybe a test group to actually prove that this helps in learning electronics even more and better?
Uh, Not really. We didn't have the time because this project was developed during a hackathon. So the HoloLens were not ours. We took them back. Um, yeah, maybe it would have been better to try to test it on people that did not develop the system in-house. I know how it works.
Well, you could actually validate then if your
Exactly.
prototype actually does what it needs to do. Eh? So you can operate it, but can someone else operate it, of course? So, and how do you see the future of your prototype? Is there a chance that you're going to follow on develop this?
Would be nice. Would be nice. Maybe not only in electronics, but as I mentioned in the start of my presentation, to use HoloLens and mixed reality to help students understand complex subjects like physics, electronics, biology. But in my specific case, in the specific case of the HoloBoard, it would be nice to keep developing. But the only thing is that I would need a sponsorship.
Yeah, I understand. I understand. So, someone was mentioning there's an echo on my mic. So I hope it's away. It's gone now. I changed the setting. So also a question I have is, so you have all these components in there. If you would like to add components to, so electronical components to the environment, would that require programming, or do you have some sort of a inventory tool that you can easily add new components with basically properties of these components so that you know how they would operate in this electronic environment?
Well, when using these kind of applications, it's just matter of taking the 3D models and put them inside the application, and inside these 3D models to program all the necessary things to replicate how they behave in real life. So, answering your question, as far as we have the 3D model of the electronic component, we should be able to program uh, this component in order to behave or to affect the circuit in the way it affects the real circuits. For example, changing the value of the resistor. If you have a higher value, the intensity of the LED will be less, or even more complex circuits. So that's what I was
So, and
thinking.
yeah, but is that pre-programmed, or is that a real simulation that actually runs behind it?
Well, would I think would be better to run it on top of a simulation that it's already working, because I mean, if it's already there and it's working, there is no point on starting from zero, starting from scratch. But again, it's just matter of getting the license or whatever is necessary to avoid any legal conflicts.
Yeah, yeah. So, and what would be the challenge? This is basically my final question. What would be the challenge to incorporate complex integrated circuits?
Again, the question: what would be the challenge to?
So, yeah, so now you're using very fairly simple components like a
Yeah,
resistor or capacitor or a potentiometer or something like that. But what would it take to actually also use bigger integrated circuits, chips
exactly.
basically, to actually make them work in the same environment.
I think that's the reason why, like, this one get us back to your previous question. It would be better to run everything on top of a already working simulator, because otherwise we would have to program every single component, every single, let's say, integrated circuits, logic gates. Mm, it's better just
Yeah,
to build on top of them, and instead of displaying in the software this 2D component, to do it in real life and in a holographic way, to place them in our HoloBoard.
yeah, yeah. Okay. So there's a question from Sean Martin from the audience. He's asking, is the HoloBoard app on also available on phone as well as on the HoloLens too?
No, this app was only developed for the HoloLens 2 to work with the holograms of the electronic components, but it would be like the natural way to also have an application doing the same things using the phone, for example, to do augmented reality, as you were saying, to use your phone to scan the schematic, and then the phone will give you how to do the wiring, how to build the circuit.
Yeah, yeah, okay. So my final question, what's the specific differentiator to use the HoloLens? So why do you use the HoloLens compared to, and this basically goes back to the question of Sean, a phone or maybe a desktop application or something like that, because that might even work.
True, like, for me, I was amazed the first time I tried the HoloLens, and I could really see how this can enhance learning in an engaged way, because you can see things that otherwise you could not. Uh, as I mentioned in the slides, maybe this is a toy example, the HoloBoard, the one that I developed. But when you are going into real solutions, the basic example for HoloLens is when they show the human body, how students of medicine can see the body in different layers without the need of actually uh, putting hands into a corpse or two models that otherwise would be cumbersome. Or you can show the body by layers, by skeleton, the muscles, different systems. So again, the HoloLens open us, and mixed reality in general open us the possibility to see things that otherwise would be not possible or very hard to do.
Yeah, yeah, I agree, and of course, and also Spandana in the chat mentions that the HoloLens is an amazing tool and does stuff that basically no other tool is doing currently. Well, there are some other examples, of course, but having this in some sort of a hologram, of course, obviously is very intuitive to work with, and I love it myself as well. Thank you for your presentation. And well, good luck with all the testing that you're doing currently. And I truly hope that your program is actually going to find the funding to actually bring it a step further into a real product compared to a, let's say, prototype or demonstrator. So thank you for that. And
Thanks for
everyone, thank you for watching today.
thanks for
You still wanted to say something?
from me, no, just to say thank you
Huh?
to all the
Okay.
viewers,
Oh,
and
okay.
thank you.
Yeah, no worries. And well, good luck with your moderator sessions that you're going to do.
Yes. So we just put
All right.
the output video, and that's it.
Yeah, I'll do that. Yeah,
Thank
let
you.
me go there. Thank you.